Welcome to Big Data Now. Today, we're diving into PySpark in Databricks, one of the most powerful platforms for big data processing and analytics. Databricks provides a unified analytics environment where you can use Apache Spark with Python, PySpark, to process massive datasets efficiently, build ETL pipelines, and train machine learning models at scale. In this video, we'll cover how PySpark works inside Databricks and why it's powerful. The 30 most important PySpark examples used in Databricks for real-world data engineering and data science, hands-on implementation of ETL pipelines, transformations, aggregations, and machine learning models. By the end of this video, you'll have a solid understanding of PySpark in Databricks and how to use it for scalable data processing. Let's get started. Part 1, Understanding PySpark in Databricks. Databricks is built on Apache Spark and provides a fully managed cloud-based environment for running Spark jobs. When you launch a Databricks cluster, it consists of a driver node that manages execution and multiple worker nodes that distribute the computation. PySpark runs on top of Spark, enabling users to execute distributed Python code seamlessly. Databricks integrates natively with AWS, Azure, and Google Cloud, providing auto-scaling, job scheduling, and built-in optimization features like Delta Lake and Photon Engine for improved performance. Now, let's explore the 30 most essential PySpark examples used in Databricks workflows. Part 2. PySpark in Databricks, 30 most important examples. 1. Setting up PySpark in Databricks. To work with PySpark in Databricks, we first need to create a Spark session. This is the entry point to Spark and is required to perform any operations such as loading data, transforming it, and running queries. In Databricks, a Spark session is often pre-configured, but explicitly defining it helps in customizing settings. 2. Creating a data frame from a list. This creates a PySpark data frame from a list of tuples and assigns column names. PySpark data frames are similar to Pandas data frames, but are optimized for distributed computing, allowing you to work with large datasets efficiently. 3. Reading a CSV file from Databricks file system. Reading data from storage is a fundamental step in any ETL process. This command reads a CSV file stored in Databricks file system, DBFS, automatically detecting column types using infer schema true. Unlike Pandas, which loads data into memory, PySpark processes data in parallel across multiple nodes, making it highly scalable. 4. Writing data to a Delta table. Databricks uses Delta Lake, an optimized storage layer that brings ACID transactions and schema enforcement to Apache Spark. By writing data in Delta format, you ensure data integrity and enable time travel queries, meaning you can roll back to previous versions if needed. 5. Creating a table in Databricks. Using SQL Databricks allows you to save data frames as SQL tables, making them queryable using Spark SQL. This makes it easier for analysts and engineers to access and analyze structured data without writing complex PySpark code. 6. Reading a table from Databricks. This command loads a table stored in Databricks into a PySpark data frame. It is useful for scenarios where multiple teams are working on a shared dataset stored in Databricks, ensuring seamless data access across different projects. 7. Displaying the schema of a data frame. Understanding the structure of your data is crucial for designing transformations and analytics. This command prints column names, data types, and whether null values are allowed, helping developers quickly inspect data without scanning entire tables. 8. Selecting specific columns. Selecting specific columns is useful when working with wide tables containing many attributes. Instead of loading unnecessary data, PySpark allows you to extract only the required fields, improving performance. 9. Filtering data. Filtering is a fundamental operation in data transformation. Unlike Pandas, which filters data in memory, PySpark distributes filter operations across multiple nodes, allowing efficient data processing even on terabytes of data. 10. Grouping and aggregating data. Aggregations are common in reporting and analytics. This command counts the number of employees in each department, helping businesses derive insights from structured data. 11. Sorting data. Sorting data is useful in ranking and prioritization tasks. PySpark ensures that sorting is performed in a distributed manner, leveraging multiple worker nodes for efficiency. 12. Adding a new column. Adding computed columns is essential in ETL workflows. This example creates a new column, new age, by adding 5 years to the existing age column. 13. Dropping a column. If a column is no longer needed, removing it helps optimize storage and performance. 14. Handling missing data. Dropping rows. Removing rows with missing values ensures data quality, especially in predictive analytics and machine learning models. 15. Filling missing values. Replacing missing values with a default value is a common data pre-processing step, ensuring consistent data sets for machine learning. We've covered 15 essential PySpark examples that demonstrate how to work with data in Databricks, from reading and writing data to transformations and aggregations. But this is just the beginning. In Part 2, we'll dive deeper into advanced PySpark operations, including window functions, joins, machine learning with Spark MLlib, and real-time streaming with Kafka. If you found this video helpful, make sure to subscribe to Big Data Now and turn on notifications so you don't miss the next part. Let me know in the comments which PySpark function you use the most or what specific topics you'd like me to cover in more detail. Thanks for watching, and I'll see you in Part 2.